Observing a specific region of the sky through the Hubble Space Telescope reveals absolute darkness. Yet, when astronomers utilized the James Webb Space Telescope to inspect the same area, they uncovered a subtle red glow, exposing a concealed, ghost-like, dusty galaxy. This galaxy stands as one of the most distant and enigmatic discoveries, offering crucial insights into the universe's evolution. In this video, we delve into the narrative behind this breakthrough, elucidating its significance and the reasons it holds importance. But before we proceed, let's give a warm shout-out to our subscriber of the week. Your engagement and support mean the world to us. To comprehend Aztec C71, the first step is understanding the galaxy's nature and how it compares to others in the universe. This involves measuring various properties, including mass, luminosity, redshift, and color. These properties can tell us a lot about the galaxy's history, environment, and potential. To measure these properties, the astronomers use James Webb's near-infrared camera, NIRCam, which can capture images of the sky at different wavelengths of light. By comparing the brightness of the galaxy with different filters, they can estimate its distance, temperature, and composition. This technique is called photometry, and it is one of the main tools for studying galaxies. The results of the photometry showed that this galaxy is massive and luminous, with a mass of about 50 billion times the mass of the Sun and a luminosity of about 500 trillion times the luminosity of the Sun. These numbers are comparable to some of the most extreme dust-obscured galaxies in the universe, which are also known as submillimeter galaxies because they emit most of their light in the submillimeter wavelength range. The photometry also showed that it is very far away from us, with a redshift of about 5.7. This means that the light we see from the galaxy was emitted when the universe was only about 1 billion years old, or about 7% of its current age. This also means that the galaxy is very red because its light has been stretched by the expansion of the universe. In fact, this galaxy is one of the reddest galaxies in the Cosmos Webb survey, which is a large-scale survey of galaxies in the cosmos field, a region of the sky that covers about 2 square degrees, or about 10 times the size of the full moon. The photometry also revealed that this galaxy is very faint in the optical and near-infrared wavelengths, which are the wavelengths that Hubble and other optical telescopes can observe. This means that the galaxy is very dusty and that most of its light is blocked by the dust grains in its interstellar medium. The dust grains absorb the light from the stars and re-emit it in the far infrared and submillimeter wavelengths, which are the wavelengths that Scuba 2 and ALMA can observe. These are the telescopes that first detected it, but they could not resolve its shape or measure its redshift. However, James Webb was able to detect the rest frame optical light from this galaxy, which is the light that the galaxy emits in the visible range of the spectrum before it is redshifted by the universe. This light can provide key information about the galaxy's stellar properties, such as its age, metallicity, and star formation rate. Webb's NIRCam was able to do this because it has a much higher sensitivity and resolution than Hubble and other optical telescopes, and because it can observe in longer wavelengths that can penetrate the dust better. The properties of Aztec C71 make it a very rare and interesting galaxy, and it challenges our understanding of galaxy evolution. One of the most puzzling aspects of this galaxy is why it was invisible to optical telescopes and how it was detected by sub-millimeter and far-infrared telescopes. To answer this question, we need to understand the physical processes that make this galaxy so dusty and red and how they affect its appearance in different wavelengths of light. The main reason why it is so dusty and red is because it is undergoing a very intense episode of star formation, which is also known as a starburst. A starburst is a period of time when a galaxy forms stars at a much higher rate than normal, sometimes up to hundreds or thousands of times faster. It can be triggered by various factors such as mergers, gas accretion, or feedback. It can also have various consequences such as driving outflows, enriching the interstellar medium, or quenching star formation. The starburst in this galaxy is producing a lot of young and massive stars, which are very bright and hot. These stars emit a lot of ultraviolet and optical light, which is the light that Hubble and other optical telescopes can observe. However, this light is also very energetic, and it can ionize and heat up the gas and dust around the stars. The gas and dust form a thick layer of clouds that surround the galaxy and act as a shield that blocks the light from the stars. This is why the galaxy is invisible to optical telescopes. The gas and dust clouds are not only blocking the light from the stars, but they are also absorbing it and re-emitting it in the far infrared and sub-millimeter wavelengths, which are the wavelengths that Scuba 2 and ALMA can observe. These wavelengths are much longer and cooler than the ultraviolet and optical wavelengths, and they can escape the clouds more easily. This is why the galaxy is visible to sub-millimeter and far infrared telescopes. The gas and dust clouds are also affected by another phenomenon, which is the expansion of the universe. The universe is not static, but it is constantly growing and stretching. This means that the light that travels through the universe also gets stretched, and its wavelength gets longer. And this is why this galaxy is very red, because it is very far away from us and its light has been stretched by the universe. The combination of these processes makes Aztec C71 a very unique and extreme galaxy, and one that is very hard to detect and study. So now let's see how this galaxy formed and grew, and how it compares and contrasts with other types of galaxies in the universe. One possible way is that it is the result of a merger between two or more smaller galaxies. This is a violent event that occurs when two or more galaxies collide and merge into one larger galaxy. A merger can trigger a starburst because it can compress the gas and dust in the galaxies and make them collapse into new stars. A merger can also create a lot of dust because it can destroy the old stars and release their metals into the interstellar medium. It can also explain why this galaxy is so massive and luminous, because it can increase the mass and luminosity of the galaxy by adding the mass and luminosity of the merging galaxies. Another possible scenario for how this galaxy formed and grew is that it is the result of gas accretion from the intergalactic medium. Gas accretion is a smooth event that occurs when a galaxy attracts and absorbs gas from the space between the galaxies. It can also trigger a starburst because it can provide fresh fuel for the galaxy to form new stars. It can also create a lot of dust, either because it can bring in dust from the intergalactic medium or because it can form dust from the metals produced by the new stars. It can also explain why this galaxy is so massive and luminous, because it can increase the mass and luminosity of the galaxy by adding the mass and luminosity of the accreted gas. I hope you enjoyed this video and learned something new and interesting. If you did, please give us a like and subscribe to our channel for more videos like this. If you have any questions or comments, please leave them below and we will try to answer them. Thank you for watching, and see you next time.